In this video, we're going to introduce counting and lists. So in mathematics and computer science, it's often important to determine how many objects there are of a certain type. So, for example, in probability, the probability of an event is the number of ways that event can occur divided by the total number of ways any event can occur in classical probability. In computer programming, if you're wondering how efficient a code is, you might need to determine how many different cases must be checked by an algorithm. And there are, in general, many cases where we want to generate all items of a certain type or know how many objects there are of a certain type. So one thing that can help us in counting is the term list. So a list is an ordered sequence of objects. And really, a sequence is automatically ordered. So if you hear a sequence of objects, that automatically denotes that there's an order to them. Lists are denoted with parentheses, and then the elements have commas between them. So this is basically the same thing as an n-tuple. Recall that an n-tuple is just sort of the extension of an ordered pair, like say 1, 3. An n-tuple is an ordered tuple with n elements in it. And the length of a list is its number of entries. So the length of list n is the same as an n-tuple. And so this is a list of length 4. We can also have the empty list. This has length 0. This is the empty list right here with nothing in it. Lists can have repeated entries, and so this is still a list of length 1, 2, 3, 4, 5. This is a list of length 5. It has some repeated entries. And two lists are equal if they have exactly the same entries in exactly the same positions. So if two lists have different lengths, that means they can't be equal. So these two lists are not equal. This is a list of length 3, and this is a list of length 2. They do not have the same entries in the same positions because there's no third entry here. If the order is different, then the lists are not equal. So these two lists, 2ABC and ABC2, have the same entries but not in the same order, and so as lists they are not equal to one another. Note that this is different from sets. So sets, recall, are denoted with braces, not with parentheses, and for a set the order of the objects does not matter, so 2ABC would be equal to ABC2 as sets, but not as lists. So some examples of lists that you have seen. Internet Protocol addresses, IP addresses, those are currently strings of 32 ones and zeros. Their lengths have changed historically, but right now they are strings of 32 ones and zeros. So each IP address is a list of length 32. As another example, license plates in Massachusetts have 6 entries, and they use the letters A through Z and the numbers 0 through 9. So each license plate is a list of length 6. And a door code, there are door codes with different parameters, but suppose one door code has a sequence of 4 numbers and the numbers are 0 through 9. That's a list of length 4. And notice these have the properties of lists. If you entered the door code 3455 and the door code was really 345, that would not get you in. If you instead entered the door code 3554, again, that would not get you in. So the repeats are important, the length is important, and having the exact same objects in the exact same order is important in each of these examples.